Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Like. Today we're going to be looking at a couple of different ways to run applications in Docker containers that are GUI based applications, but get those results back inside of a browser. Let's dive right in and start talking about X server on Windows containers. So this is an interesting topic that we've already done one video on, and what we're trying to do is look at how you can deliver desktop applications, that is applications with a graphical user interface using containers, which are typically not used for that. They're typically used for delivering things that don't have UIs, or if they do have a UI, it's usually something like a web page or a remote client of some kind. And what we're trying to do is take native UI applications and put those into a container and figure out how we can get the graphical user interface on something that is outside of the container so that we can actually interact with that app. And that's really what we're looking at today. Last time we looked at something different. We looked at a different kind of approach for doing this. We looked at using a remote server for building our applications. And the remote server basically looks something like this, where we had an X server and we had an application that interacted with that. And so on any Linux box, you have this X server, and that X server is interacting with an application and it's sending commands back and forth to that application. And then you have a mouse and keyboard that interact with X, and it captures the mouse, captures the keyboard, and then puts that input back into the application. And then it's also responsible for writing out something to a display, which in the case of most computers would be a monitor. But it can also be the case that that X display can be remote. It doesn't have to be a monitor on the physical machine that's actually running the actual X server. And that's due to the nature of the way that X is decoupled from the app and from the actual physical hardware itself. And last time we looked at how we could put a container around the application and then take the output from that application and stream it back to an X server that was outside of the application, outside of the container, and then interact with that app that way. And we used an X server for Windows to do just that. Well, with this iteration, we're going to look at how to do this slightly differently, where we have a remote client. In this case, what we're going to look at is we're going to have an app, and that's going to interact with X, just like we saw in the other demos that we did, where we had a remote X server. But the X server and the app are actually going to be in the same context. And then we'll have a remote client that will connect to the X server. And then that remote client will capture the keyboard, mouse input, and it will also act as an output for the display. Now, this remote client can be any number of different client softwares. There's several of them that are out there. The one that I'm going to be primarily looking at today is VNC, and how you can use that in a browser context. And there's another one I actually want to look at too, that is not so much a VNC client, but it does give you the same basic functionality that VNC would, and I'll show you why I prefer VNC over this other one whenever we go through the demos. But in any case, we put a container around X server and around the app, and so the container itself will contain the X server and the app. And rather than use a physical display and physical memory, what we end up doing inside that X server is we have a virtual display that has a frame buffer, just like a video card would. And then what you can do with that virtual display is capture the output as a bitmap and then create a stream from that. That could be just a video stream or a proprietary protocol like VNC, and then push that over to a remote client that understands that and then display that on some way on that remote hardware. So that's kind of the approach that we're going to be looking at today, is this one right here. I'm here inside of my virtual machine where I have my Docker for desktop environment set up. In this case, what I have here is a Docker for desktop running Linux containers, and I've already built an image using this Dockerfile here. Now, for this particular Dockerfile, I'm going to be using a project called Xpra. Now, Xpra is a project that is designed for running X applications on a remote client. So it has a client and a server component that goes with it. The server component is an X-based software that is optimized for streaming streaming apps over a network, but instead of using a remote X server, it's using a local X server, and it uses a specialized protocol that's adaptive to the network conditions of the application and where it might be streaming. So it can do things like adjust frame rates or adjust compression on the output in order to adapt to the available bandwidth. So this is ideal if you have a slow connection or a fast connection. You can serve up the application and get a fairly good experience regardless of the kind of bandwidth that's available to you in whatever environment that you might be running. And also Xpro is incredibly easy to install. And this one I'm just using a bunch of apt-get commands. I'm doing an apt-get command install AbiWord because that's the application we'll be demoing. These other packages are basically for enabling me to use a third-party repository, which is the Xpro repository. And then after I add that to my repository list, I can run apt-get on Xpro, and then I can set up Xpro to run on the CMD for Docker. And here I'm just calling start, and there's the command to start AbiWord. I'm binding to every possible IP address on port 10,000, and then I'm setting this HTML flag to on so that it will know to use the HTML. And this basically just keeps the container from exiting because Xpro is going to go into what is more like a daemon mode rather than running in the foreground, and it will transfer the control back to the foreground to the actual bin shell, and then it will exit and the container will exit, which I don't want. So I'm saying tell the null device here, and that will keep the container up and allow me to connect to it. So in any case, let's go ahead and run this. I've already built it, so I'm not going to run a Docker run command, a Docker build command. I'm simply going to run Docker run here, and then I'm going to do a Docker run, give it a port number, in this case 8080, which should be fine for this, and port 10,000, and that should be the only parameter I need. And then I'm going to give it Xpro for the image name and run that. And once that's up and running, I should be able to connect to it with a browser. So let's go ahead and see what this looks like. Launch a browser, go to http:/localhost and 8080. And there it is. It just took a minute for it to load. And there's AbiWord. Now, Xpro is kind of nice because it gives you like this kind of pseudo desktop here where you have these windows and you can drag them around and you can maximize them, minimize them, close them. And Xpro really allows you to run more than one application in this particular context here. The ability to do this gives you some kind of multitasking. However, if I was going to be running this, I would actually have multiple applications running in different tabs in the browser rather than trying to have one actual browser container that runs all of my applications. Another thing with this is it does seem to be a little bit laggy depending on the context. In this case, you can see that it's refreshing my screen quite a bit, and that's because I think that there's some issues that I'm doing a lot of nested virtualization here, and it's really taxing the CPU that is running on the virtual machine that's running another virtual machine to run these Docker containers for the purposes of running this actual demo here. So I can go Blaze is typing into this window, and you can also see that it's working fairly well now. And once you have this all up and running, you can then type and do whatever you want to inside your application. So this is Xpro. Again, one way to do this. I'm going to switch over and look at another possible way to do this in just a second. Now for this next one, I'm going to be looking at how to use VNC to do the very same thing that we did with Xpro. Now Xpro wrapped it all up in a single package to where it exposed not much of the details. You really didn't have to deal with installing X or working on any of those other kinds of things. You basically just install Xpro and it handled all those details for you. But I'm going to switch over and walk through the stack that I'm going to be using for VNC because it does expose all of those nitty-gritty details to you. So you have to kind of know what you're doing in order to get this to work. And the first thing that you need is obviously an application, which in my case, I'm using AbiWord, but you can use any X app and it pretty much will work the same way. And then on top of that, you need a desktop compositor. And desktop compositor is the component that is responsible for allowing you to resize windows, layering windows on top of one another, maximizing, minimizing, and all that kind of thing. And it interacts with your X server. And the X server is the piece that is responsible for capturing the input from the mouse and the monitor, mouse and keyboard and other input devices, as well as outputting that to a monitor. But in the case of a container, we don't have a monitor, so we need somewhere to write that to. And that's where virtual frame buffer comes in. And this acts like virtual video memory. And the X server can write to a virtual frame buffer, and it allows you to output to that as if it were a virtual graphics card in this case. And once you have that, a virtual frame buffer installed, you can then tap into it with other projects like a VNC server. And Turbo VNC is the one I've opted to use here, mainly because Turbo VNC can have interactions with OpenGL, which in the context of Linux is used for graphics acceleration. So it interacts with 2D and 3D accelerators that are hardware on a physical CPU or GPU, and it can expedite the rendering of animations and then serve those back to the client without having to do software rendering of those same animations. And most modern CPUs have integrated GPUs in with them anyway, and so you can actually use OpenGL within a container and still take advantage of some of that acceleration that it comes with that OpenGL acceleration. And Turbo VNC, working with Frame Buffer, can then take the output of that and serve it back to the client, and it feels much more quick in its responsiveness because it's taking advantage of some more hardware acceleration that way. But VNC by itself is not a technology that will allow you to connect a browser directly to it. So you need to put a wrapper around that protocol. And you can do that by way of a project called WebSockify. And what this does is it takes just a standard socket app like Turbo VNC and puts a wrapper around it that allows you to run it through a WebSocket. And a WebSocket is a technology that allows an HTML5 application to communicate over a socket connection that is using TCP-based sockets, but there's a handshake that's got to happen before that can occur with the web server. So the web server's got to be able to support WebSockets, and WebSockify basically acts as a wrapper around a standard socket and the WebSockets protocol to bolt up an HTML5 app to a standard TCP stream. But once that's done, then you can have a browser connect to WebSockify, and WebSockify proxy the TCP output, which in this case is going to be VNC. And then with WebSockify, you can use Real VNC inside of a browser. Real VNC is a project that allows you to have an HTML5 based VNC client running in the browser that allows you to do mouse and keyboard input, as well as uses the Canvas API in HTML5 to render the graphics that is being outputted by your application. So it's a fairly involved stack, and I'm going to show you the Dockerfile that accomplishes all of this in just a second. Here's the Dockerfile that I'm actually using to build that stack that we just looked at. And this is doing a lot more than the other one did, where we're basically just running a bunch of apt-get commands to install some packages. This is actually having to get some third-party packages as well as some first-party packages from the Ubuntu repositories, and then configure the whole stack. So here we have AppyWord, which is probably the easiest part of this whole thing to install. Here are the packages that basically allow me to use some third-party packages as well as third-party repositories. Here's Rat Poison, which is the desktop compositor that we saw as part of that stack. There's No VNC, which is the HTML5 client for VNC. And WebSockify is the wrapper around the VNC server. And here's some of the OpenGL libraries that are needed. And then here are some X libraries, and then type VNC is installed on this because I need it for some of the utilities that are involved with that. It's not the actual VNC server that I actually use though. This basically configures some of the output so that I can use a headless install. That's what these parameters are doing right here. So that I can do non-interactive installs. It's setting some variables here for allowing me to select time zones, which are needed to install some of these packages. And once that's configured, it downloads some deb files, which are Debian packages that Ubuntu uses, and then uses dpkg to install virtualgl, which is a OpenGL library for doing that hardware acceleration that we talked about. And then Turbo VNC, which is the optimized version of VNC for hooking into OpenGL and then giving some tight compression on that output so that I can have very fast performance inside of a browser application. And this is configuring the password for VNC. So it's basically just writing out this very secure password right here. And then it's configuring Rat Poison, which is that desktop compositor. So I'm setting a border of 1 around that, and then setting the exec to AppyWord, which in this case is the app that I'm going to be demoing for this one. This is a self-signed cert right here. And then this command is where it glues all this together. At first it starts being the VNC server, which is Turbo VNC. And then it starts WebSockify, which wraps around that VNC server. And then WebSockify exposes a web folder right here, which is the No VNC client. That's the HTML5 client that goes in front of the VNC server. There's the cert that we generate. It's running on port 80 and it's exposing port 5901 on localhost, which is the standard port for the VNC server. And then finally, it's using tail to prevent the container from exiting because all these other ones go into a daemon mode. So this is much more involved. There's a lot more to it than what we saw in the previous demo here. But suffice to say, though, I think this one works a lot better. We saw some of that lag in that last demo, and I want to demo this one to show you the better performance here using this particular setup as well. And there are some caveats that you'll see as well. So to make this one work, let's get the name of the image. I think I called it Docker images, and I called it VNC Abbey Word. That's the name of the image I used. So Docker run, and then let's call Docker run, and then do port, let's say, I don't know, 8081, in case I have anything running on port 80 already. And I'm gonna map that to port 80 because that's what the WebSockify server is gonna expose. And then I'm going to tell it the name of the image I'm gonna use, which is VNC-Abbey Word. And that will run this. Now everything is up and running, and I should be able to pull this up in a browser now. Let's go ahead and pull up localhost :81, and it's going to be a list of files. Localhost 8081. That looks good for my VNC server, and let's type in that super secure password one, just to make sure I typed everything in right, password warn you, and connect to this. And this is Abbey Word running in this context. Notice it's not there's no window bar up here where I can drag and drop and multiply, maximize things. I can resize it, doing resizing the actual zoom on the browser if I need to zoom in a little bit. But all in all, this is a application running inside of this particular environment. Now, this is using OpenGL to render some of these screens here, and the animation on this seems to be a lot smoother than what I might otherwise have for a application that Xpra didn't seem to work as well. And I like this one a lot better because the application performance does seem a lot better than what you would get with some other demos that we've looked at. It's almost, I won't say it's native speed, but it's pretty good considering that this is streaming through a TCP socket and the size of the stack that is actually running, and then streaming it back to a browser and then putting this onto an HTML5 canvas. So I think the performance of this is nothing to scoff at considering what it's actually doing to make it all work. And I think it is much more performant than what we'd expect. So let's close this out and let's run a similar version of this where we can look at Chrome running in this exact same stack, but instead I'm going to use Chrome because Chrome uses GPU acceleration to do some of the animation, and I want to use that as a demo just to show you how the OpenGL works with this. So here's the Docker file for Google Chrome. Basically, the only difference between this one and the other example I looked at is this one is installing Chrome. It's installing this from a deb package as well. And so you can see here, I'm using apt install Chrome right here from that deb package. And then I'm using dpkg to install those other packages. And it's setting the exec right here to call Google Chrome. And in this case, it's calling it a no sandbox mode because I am using root here, which is a no-no inside of the containers, I know, but for this demo purpose, I think this is okay. But in any case, let's go ahead and run this and see what happens. And we will see the performance difference between this one and we get to see some of the acceleration that OpenGL is providing us when we actually run this one, because this is a fairly heavy container from a graphics perspective. So let's go ahead and run, get a Docker images to see what the name of this one is. And I think this one is called VNC Chrome, which let's go ahead and get this one. So Docker run, let's go -P, let's use port 8082 maybe for this one, and then map that to port 80, and then call VNC Chrome and let this run. And now this is going to launch Google Chrome when I log into this particular container here. So let's open up a new tab and localhost 8082. And launch this particular one and let's set this port to 8082. I'm not running on 8081 anymore, and use the same password one right here and super secure, I know, and then log into this. Now this is the first time I've launched Chrome, so you get that launch, make your default browser automatically send crash reports, that kind of thing. And I'm gonna make it my default browser since it's really the only thing running here. And this is actually doing some animation on the screen right here. And I wanted to show you this animation here because this animation, if it was simply running this without the OpenGL context, would be very rough, and it would actually drag this thing to where it was almost unusable. And that's because this is using OpenGL to render this animation, and that is using hardware acceleration on my local machine here. And you can go to pretty much any website you want and winelect.com, and the speed at which this renders is much faster because it's able to take advantage of some of that hardware acceleration. And it is still not native speed, but it is much better than what I think you would expect if you were running this in something else. And we actually did another demo where we did Chrome with the option of using X outside of a container, and it was a lot more choppy than what we would expect here. So this is a GPU-enabled application that's running very well inside of a browser context that's being delivered by way of a container. So again, I think that the VNC option here is best for applications that need speed of rendering. If you have a lot of animation GPU enabled, a lot of intense graphic type workloads, probably not ideal for 3D workloads, but for things like browsers, IDEs, and a lot of applications that need that advanced rendering from OpenGL, this would be the way to go. Otherwise, XPro might be the way to go for some of those other types of workloads if you're using those. But in any case, here are two different approaches to do something very unique inside the Docker context, which is running desktop applications and delivering those back to a browser using container. Now, next time we're going to look at a couple of ways that you can use this as a way to deliver these applications and maybe do a proof of concept for where you can have an environment where you can use containers to deliver applications and have the storage and everything associated with that container on a per user basis. And then you can have something like a application farm that gets delivered through a browser that allows your users to run applications that might otherwise be desktop applications on Kubernetes, but in that case, we can actually run them as virtual desktops instead of having to run something like VMs to do that very same thing.
If you like this content, please consider visiting us online at www.wintelect.com, and there you can find about services that Wintelect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintelect on Twitter at WintelectNow or at Wintelect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintelect.com. Until next time, thank you.